All right, so we're going to solve inequalities. All right, so number one, and just kind of see if you remember anything from last night. So if I have this, so it's going to say graph the solution set and write the solution in interval notation. Okay, you can still see that, right? I turned the light off because it was having, the glare was having an issue with this. Okay, so number one, let's suppose we had negative 4x is less than 20. So I want to solve this inequality. Now remember, it's not an equation. If this were an equation, though, what would you do to solve for x? Divide both sides by 4. Negative 4, excuse me. But is it an inequality? How many solutions will there be here?
Infinite.
An infinite number. So when we solved the equations, you just listed them because it was a finite number of solutions. Either, in most of the cases, we got one solution or two solutions, depending on if it was linear, quadratic, or absolute value. But in this case, you have an infinite number of solutions, so we're going to graph the solution set instead because you can't list them finitely. So how are you going to solve for x here? Divide both sides by negative 4. So I'm going to go ahead and rewrite this. All right. Anything else you want to tell me? You've got to reverse an equality symbol because you're multiplying or dividing both sides of an inequality by a negative number. Right, so that's one of the things we discussed yesterday. So you must always remember to do that. So I'm going to circle this to remind myself that I need to do it. So when I simplify each side, negative 4 divided by negative 4 is 1. 1 times x is x, but I've got to say x is what? Greater than a negative 5. Okay? So my solutions, the solutions to the original problem, the original inequality, would be any number that's bigger than what? Negative 5. So any real number bigger than negative 5. So there's an infinite number because you have all kinds of decimals, you have irrational numbers, you have rational numbers. There's an infinite number of them that's bigger than negative 5. So on the number line, if this is 0, you're going to put negative 5, which is on the left. All right, now I need for you to use parentheses or brackets. So is this going to be parentheses or brackets? Parentheses pointing which way? To the right, like this. And then I shade in the number line pointing to the right. Make sure you draw an arrow. Okay? Draw an arrow, just like I did here. Okay. So that's the graph of the solution set. The solution set written in interval notation, you read a graph from left to right. So where do I start?
Negative 5.
Negative 5. Can I include negative 5? Is negative 5 a solution?
No.
No. All right, and you can check and see why it's not true. What's negative 4 times negative 5? Positive 20. Is 20 less than 20? No, 20 is not less than 20. 20 equals 20. But any number bigger than negative 5 is a solution. So for example, 0. 0 is a solution, right?
Mm-hmm.
Negative 4 times 0 is what? 0. 0 less than 20.
Yep.
Yeah. Why is negative 8 not a solution? Why is negative 8 not shaded?
Because it's less than the negative 5.
Negative 4, you got to go to the original though. Negative 4 times negative 8 is?
Positive 32.
Positive 32. Is 32 less than 20? No. All right. Okay, interval notation, how are you going to write that?
Open parentheses.
All right, so parentheses.
Negative 5. -5,
comma,
infinity,
infinity,
open close
parentheses. All right. Okay. Now, one other thing I need to remind you before we actually look at some problems that are a little bit more detailed. What if you had this? What if I asked you to solve this inequality? 2 is greater than or equal to x plus 3. Okay? And if this was an equation, then what would be the quickest thing you would do?
subtract 3 from both
Subtract
sides.
3 from both sides. So let's do that. Let's subtract 3 from both sides. So I get, when I subtract 3 from both sides, what's 2 subtract 3? Negative 1. I'm going to ask you this. Do I need to reverse an equality symbol? No. Only if you divide or multiply by a negative number. I'm not multiplying and dividing by a negative number. I'm adding a negative number to both sides. So negative 1 is greater than or equal to what number? Or to what expression?
-1.
No.
Oh,
0, x, right? X.
okay.
Okay, so you got to be careful with this one, though. On the number line, I have to use what number?
-1.
Negative 1. Parentheses or bracket?
Bracket.
Okay, so bracket because of the equal sign. All right, now here's the issue. Am I going to shade to the right or to the left of negative 1?
To the left.
Okay, so someone said to the right. Why would you say to the right? Because of the greater than? Because when you think of greater than, you think
Bigger signs.
bigger than? Hold on.
Because I always looked at it as an error.
Okay, so those of you that said to the right, those that said to the right, you said it because you see that symbol greater than, right? But you got to also remember, where's the x located? The x is located on the right-hand side. There is a difference between this right here and this. That would be everything shaded to the right of negative 1. That's not what this is. So you got to be careful where the variable is located. Normally, when I solve it, I always tend to put the variables on the left-hand side, so that way I don't make that kind of error. But basically what you're saying is this. Negative 1 is bigger than any other number for x. So in other words, negative 1 is going to be the largest solution, right? All your other solutions are going to be what? Less than that. So if negative 1 is your largest solution, then you got to shade into which side? To the left. So there's going to be a bracket pointing to the left. Now it is a little confusing for some of you. So what I would do then is, if when you solve a linear equation and you have the variable on the right-hand side, write it going backwards. Rewrite it. So negative 1 is greater than or equal to x means the same thing as x is less than or equal to negative 1. So just rewriting it backwards. See where the pointed part of the inequality is towards x? Keep it the same. You see this right here? Keep it the same. All right. So negative 1 is greater than or equal to x means x is less than or equal to negative 1. Okay? All right. So just be careful, because some of you, when you look at this, you're going to think this, and that's not what it is. All right, so I just want to bring up this real quick, just in case we get to situations where you do bring your variables to the right-hand side. All right, number 3. Let's suppose in number 3 we have this. We have 7x minus 2 is less than 3 times x plus 1 minus 4. It's not that difficult because it never is difficult. It is not that difficult because you've had this kind of situation before. If this was an equation, what would you do? You would distribute first,
Move everything to one side.
right? And then you bring all the variables one side, constants to the other, because it's linear. This is a linear inequality. You do the same thing with inequalities. The way you work equations, you can use the same idea. So I'm using distributive property first. So I get 7x minus 2 is less than, if I distribute,
3x
I get
plus
3x plus 3 minus 4. What's the next step? Combine like terms. So I get 7x minus 2 is less than 3x minus 1.
negative 1, minus 1.
All right, now, we're dealing with a linear inequality. The rest of this is the same way you would do a linear equation. So bring all the variables to one side, constants to the other. It's always a good idea to bring the variables to the left-hand side. So I'm gonna subtract 3x on both sides. Did you turn in your worksheets that's due today? Turn them in, please. 7x minus 3x is
4x
4x minus 2 is less than
negative 1.
-1. Next step,
Add 2 to both sides.
add 2 to both sides. Combine like terms, 4x is less than +1. Okay? All right, now, I'm going to go ahead and rewrite this over. What's the next step?
Divide both sides by 4.
Divide both sides by 4. So my solutions would be any real number less than what? 1/4. So the solution to the original inequality, would be any real number less than 1/4. So in the number line, when you look at the number line, it'll be numbered. So if this is 0, this is 1, this is 2, and so on, you're going to have to put what number on that number line? 1/4. So you're going to have to estimate where 1/4 is located. 1/4 is located between what two integers?
0 and 1.
0 and 1, closer to which one? 0. So let's say 1/4 is here. All right, so let's say this is 1/4. All right, notice how I wrote the 1/4. I put the 1/4 there, so make sure you do that. Just put it underneath something like this. All right, parentheses or brackets?
Parentheses.
Going which way? To the left. So like this. And make sure it looks like a parentheses. Don't make it look like a bracket. Don't let me guess as to, is this person writing a bracket or is this person writing parentheses? Make it somehow to where I can understand which one it is. Yes? What's your question? Okay.
I actually had that question.
What's your question?
Do we not flip the sign since we were dividing the 4x?
It's not negative.
Well, it's not negative.
Okay.
Only if you divide or multiply by a negative number. Okay. All right. So there's your graph. So how many solutions are there?
Infinite.
An infinite number. All right. Now, how do you write this interval notation? I notice the arrow. The arrow is pointing to the left, correct? And it's pointing towards what idea, what concept? Negative infinity. And whenever you deal with infinity, negative infinity, you're always going to use parentheses, regardless of whether you see equal signs or not. So you're going to say parentheses, negative infinity, comma, 1/4 with parentheses. So there's your interval notation. Now make sure when you write interval notation, go from smallest to largest. That's why we say always read from left to right. Okay, some of you, there's always a couple that are going to do this. You're going to say 1/4, comma, negative infinity. And you're going to be very upset with me. But I can handle you being upset with me. Okay? That is not correct. All right, that's number 3. All right, let's look at this one. Number 4. All right, so number 4, let's suppose we had 6 minus 2 times x minus, let's say 5, is greater than or equal to 3 minus x. Okay. So think about if this was an equation, if this were a linear equation. If this were a linear equation, what would you do?
Distributive property.
Distribute. Now, hopefully by now you know you don't say 6 minus 2 first and distribute the 4 because you know that's incorrect. The order of operations says I got to multiply before I subtract. So you distributive property. So I get 6 minus 2x
Plus 10.
plus 10 is greater than
Equal to
3 minus x. That's where we're at.
Combine like terms.
Combine like terms, so I get negative 2x plus 16 is greater than or equal to 3 minus x. All right?
Add x.
Yeah, so let's bring the variables to the left-hand side. So I'm going to add x to both sides. Combine like terms. What's negative 2x and x?
Negative 1x.
Or just negative x, right? Plus 16 is greater than or equal to 3. Y'all agree? Okay. What's the next step?
Subtract 16.
Okay. And combine like terms, the 16s add to 0, so I get negative x is greater than or equal to what number?
Negative 30. Oh,
Negative 13.
yeah, okay.
All right, now, I got to get x by itself. I don't have x by itself. What do I have on this side?
Divide by
Negative x. So for some of you, if you don't see this, you may want to rewrite negative x as negative 1x. But you want a positive 1x. So you got, right now, multiply by negative 1. What's the opposite of multiply by negative 1?
Divide by negative.
Divide by negative 1. Now, since I'm dividing or multiplying by negative number, I've got to reverse this inequality symbol. So, so negative 1 divided by negative 1 is 1. 1 times x is x. So what is x?
X is less than or greater to 13.
Positive 13. All right, so x is less than or equal to 13. Okay, the question at this point. Make sure you understand why I reversed. Okay? Why did I reverse the equality symbol? Because I divided or multiplied both sides by a negative number. All right, now on the number line, if this is 0, I would have to put bracket or parentheses.
Bracket.
Bracket on what number?
13.
13. So if I say this is 13, will the bracket be pointing to the right or the left? To the left. Make sure it looks like a bracket, okay? Shade it in and then draw an arrow. All right, so there's your graph. What's the interval notation?
Parentheses, negative infinity, comma 13, close bracket.
All right, everyone agree? Okay, all right, so that's number 4. Number 5, let's see. All right, number 5. Okay, number 5, suppose we had this. 2x minus 3 divided by 5 minus 2 is less than x divided by, that's an x, divided by 2. All right, now you had this kind of situation when you solved those linear equations, when you had those fractions. So what did you want to do? Find the LCD because you want to clear your fractions, right? So what's the LCD? 10. So the LCD is 10. Remember the steps I need for you to show me, okay? So you're going to I'm going to go ahead and rewrite this over. So I get 2x minus 3 divided by 5 minus 2 is less than x divided by 2. Now remember the steps you got to show me. So if you notice on the left side, there are two fractions. You have this fraction here and then negative 2 divided by 1, right? So you can put that in parentheses. So you can say parentheses. So because both of those fractions have to be multiplied by 10. On the right side, I don't need to put parentheses there because it's just one fraction. So you got to remember all that stuff we talked about that first week of class. So now I'm going to say times 10 times 10. All right, so that's where I'm at. So that 1 point, I think it's 1.2 part 1 or something like that, or part 2, that worksheet. So you'll notice that it looks like this. Then, remember, you're going to get rid of the parentheses by using what property? Distributive property. Now notice when we wrote this, now before I go on, what some of you did, and hopefully you've corrected that error, but what some of you did, a few of you, most of you did this correctly when we did equations, but what some of you did was you said 5 into 5 is 1, 5 into 10 is 2, and distributed a 2. Is that correct? No, because you don't say 2 times 2, you got to say this negative 2 times what? 10. So you have to distribute first and then reduce. So I'm going to say 10 times this fraction and then 10 times negative 2. So 10 times 2x minus 3 divided by 5 minus 10 times 2, just like this. It's less than 10 times x divided by 2. So that's where I'm at. Okay, then, so I distributed, then we reduce. 5 into 5 is 1, 5 into 10 is 2. But then you may recall that what else did I need here? Parentheses. Because all of this has to be multiplied by what? 2. So really what I have is this. I have 2 times 2x minus 3 minus, and this is just what? 20. It's less than, let's reduce this. 2 into 2 is 1, 2 into 10 is 5, and that's just what?
5x.
5x. All right, so that's where I'm at. So nothing new here in terms of what we've done before. The only difference is that in the past we had equations, now we have inequalities. All right, then what's the next step? Distribute the 2. So I get 4x minus 6 minus 20 is less than 5x. Next step,
Like terms.
4x minus 26 is less than 5x. All right, so that's where I'm at. All right, now, a couple of paths I can take now. So remember this inequality, and one of the things you may say is, well, I don't want to mess up with my inequality symbol, so I'm going to bring all the variables to the left side. You can. Or if you want to, you'll notice that on the right side, it's just one term, and it's the variable, right? So you may say, well, I want to bring the 4x to the other side instead. You can do that as well. So I'll do it both ways, so you'll see the idea you have to take in each case. So I'm going to go ahead and do this both ways. So let's bring the variables to the left-hand side first. So if I do that, I'm going to have to subtract 5x from both sides, right? If you do that, and here's what you have to say, though. Minus 5x, minus 5x. And notice I'm aligning my like terms. Then I combine like terms. What's 4x and a negative 5x? Negative 1x or negative x minus 26 is less than what? You have to say the 0. 5x minus 5x is 0. You got to say, you got to have something there. Then add 26 to both sides, just like that. Then combine like terms. I get negative x is less than 26, but I got to get x by itself, so I'm going to go ahead and rewrite that negative x as negative 1x. I just rewrote it over. Now finally, what's the next step? I'm dividing by a negative number, so I've got to reverse this. So negative 1 divided by negative 1 is 1. So my solutions would be any real number that is greater than negative 26. Okay? So when I graph it, This is 0. Am I going to use parentheses or brackets?
Parentheses,
I need to put parentheses on what number?
negative 26.
Negative 26. The parentheses has to be pointing which way? To the right, because I'm going to be shading in all the numbers that are bigger than negative 26. Just like this. Make it look like a parentheses. And there's your graph. Interval notation, read from left to right. So I start at negative 26 with parentheses, comma, infinity with a parentheses. Okay? Now, if I had instead, I'm going to go ahead and rewrite this over here, or, right here, or, let's say we had this. So let's say someone said, well, I'm going to bring the variables to the right-hand side. Okay, that's fine. You can do that. Does not matter. What would I need to do?
Subtract 4x from both sides.
Subtract 4x on both sides. Combine like terms. This is 0. 0 and a negative 26 is a negative 26 is less than x. You're done. Because you got x by itself, right? But the problem is that for a few of you right now, by the time you take the test, you won't have that issue. But a couple of you, when you put negative 26 on the number line, and you put parentheses, you're going to see this less than, yes. I'm sorry, say it again? No, I don't want you to do that. I said yesterday I was going to do that, but then on My Math Lab, they use parentheses and brackets. I want you to be consistent with My Math Lab. Now, in general, it's still correct, but I need for you to be consistent with My Math Lab. So I want you to use parentheses and brackets, not open circles or closed circle. Okay? All right. But mathematically, it is correct to use either one. Okay. So negative 26. What some of you a couple of you going to do is going to see this less than symbol. You're going to say, I'm going to shade everything to the left because less than you think left. That's not the case here because where's the variable located? On the other side. So you need to rewrite it. So negative 26 less than x means x is what? Greater than negative 26, which is what we had here. Okay? All right. So just remember, it doesn't matter which way. Just be careful when the variable's on the other side. So if you're not careful in both cases, you're prone to make an error. So for example, those of you that divided by -1, you may have forgotten to reverse the inequality symbol. Those of you this way, where this is correct, you may forget that you don't shade to the left, you actually shade to the what? To the right. So either way, you're prone to make an error if you're not careful. All right, so we're going to do one more with a fraction. So let's say we had this one. Number 6. So let's say we had 2x minus 1 divided by, let's say, 4 minus, and let's say this is 3 minus x divided by, let's say 6 is less than or equal to 1/3.
Get up on the fly, Anna.
All right. What's the LCD? 12. All right, so multiply both sides by 12. So the smallest number that 4, 6, and 3 go into is 12. Could someone multiply both sides by 24 if they wanted to? Yeah. As long as you have a common denominator, but it's always easier, more efficient to use the least common denominator. Now, when we do with inequalities, we're not going to do variables. With equations, we had variables in the denominator. Remember that? That's one of the things you had to turn in today. But with inequalities, you're not going to have that. But when you do the variables, you do want to use the least, because if you don't use the least, when you multiply both sides by the least common denominator, it becomes very complicated. But since those are numbers, you can use any common denominator. All right, it's going to multiply both sides by 12. So the LCD is 12. So since the left-hand side has two fractions, I'm going to put that in parentheses, just like this. All right, so we'll say times 12 times 12. I did not put the other side in parentheses because it was just one fraction. Now, do I say 4 to 12 first and then distribute that? No. You got to do what first? What I'm saying is this. 4 into 4 is 1. 4 into 12 is 3. Do I distribute the 3? No, you got to distribute first because you're not going to say 3 times this fraction. You got to say what? 12 times this fraction. We talked about that in the previous example. We talked about it last week as well. You have to distribute first. If you reduce first, you're distributing the wrong number. So you have to distribute first. You got to say 12 times this and 12 times this. So you can say 12 times 2x minus 1 divided by 4, and I'm going to put parentheses around the numerator, minus, and then 12 times 3 minus x divided by 6, I'm going to put parentheses around the numerator, is less than 12 times a third. So that's where I'm at.
Note that each one of the parentheses has to be multiplied by 12. Do we have to write it out, or can we just skip that step?
What do you mean?
Well, because like whenever I
You mean to go from here to here?
I don't write that step.
Yeah, like that's
What step are you talking about? This step or this step?
That step.
This one?
Yeah, because I already know that I have to multiply both.
But you did this, right?
Yeah.
So what will be your next step?
Well, then you would, it would become a 3.
What would be?
3 and then this 3.
Oh, so you're saying you would.
Yeah, I'm just saying like
Instead of
4.
step
like,
two.
I-
But you would say at some point you would show this, right?
Yeah.
Okay, because you got to show enough for me. All right, you have plenty of time to take a test. Don't be lazy and lose points because you didn't show me enough.
Mr. President,
Okay? Yes.
I think she's talking about doing it the way that I've been doing it, where I just multiply the number by all parts separately.
No, I was just wondering like if I had to show that step.
Well, you could have skipped one of these steps as long as you are showing me enough. Okay. So when you turn in the worksheet and there's a little comment that says something, make sure you follow that comment. Okay, over here you're going to say 6 into 6 is 1, 6 into 12 is 2. So you can say minus 2 times what? 3 minus x. It's less than or equal to 3 to 3 is 1, 3 to 12 is 4. So that's 4 times 1, which is 4. Okay? So at some point, I do need to see this, because I need to see the fact that you are distributing a what here? A 3, and I need to see the fact that you are distributing a what here? Negative 2. Okay? So what is this right here? Minus 3. What's this right here? Oh, nope. Negative 6 minus, plus, yeah, negative 6 plus 2x. This is less than 4, right? A couple more steps and you're done. What's the next step? Yeah, so what do you get when you combine like terms?
4x minus.
Nope. 8x minus 9 is equal to 4. What's the next step? Add 9 to both sides. Now I made it up so you got this, yeah. So I get 8x is less than or equal to 13. Then I got to divide both sides by 8. And so my solutions would be any real number less than or equal to 13/8, right? All right, so I ended up with this improper fraction. Y'all agree? Now you got to put that on the number line. So some of you, if you leave it as an improper fraction, and you try and think, well, where is it located in the number line? You may have an issue. So what you may want to do is think about what is this improper fraction as a mixed number. So it's 1 and 5/8. 1 and 5/8. Okay? So in the number line, if this is 0, this is 1, this is 2, and this is 3, let's say. 13/8 is between what two integers? 1 and 2. So here's 1, here's 2. 13/8 is 1 and 5/8. 5/8, okay, is more than halfway. Because 4/8 in the middle, right? So I'm going to ask you this. Is 13/8 closer to 2 or closer to 1? Closer to 2. So just make it look closer to 2. So let's say it's about here. All right. Now what I would do at this point is just say 13/8. Right, it's 13/8. These are an improper fraction. But we wrote it as a mixed number so I can kind of have an idea of where it's located. Now if you want to put it as 1 and n 5/8, I have no issue with that. Right here, no issue. So now you do understand that this is an improper fraction, right? The one we had earlier, I think it was a 1/4. What kind of fraction is that? Proper or improper? Proper. Improper fractions you can write as what kind of number? Mixed number. So all these years you thought that you didn't need to remember all of this stuff, right? I told you, so at day 1 of your life you started learning math. All right. Now brackets or parentheses? Brackets going which way? To the left. So like this. Draw the arrow and you're done. There's your graph. Now, as an interval notation, the arrow is pointing which way? Towards negative infinity, to the left. So you read a graph from left to right. So you're going to say negative infinity. Now, I have an equal sign here. Do I say bracket negative infinity or parentheses negative infinity? Parentheses. Whenever you're dealing with infinity to negative infinity, you must always use parentheses. So you're going to say parentheses negative infinity, comma. You can say 13/8 or you can say 1 and what? 5/8. It does not matter. And then what do I put though? Bracket. All right, and so that was it. Okay? That's all this is. All right, now let me give you the worksheet that goes with this.